INEOS gel coats are well known for providing reliable, durable, real-world performance. To achieve this performance, it is important to properly apply the product. This video will outline all key aspects of patching INEOS gel coats in a manner that is safe and will provide lasting value to the end user. Safety. Be sure to follow all safety procedures outlined by OSHA in your manufacturing facility. Before working with gel coats, review its safety data sheet. Take note of all safety precautions and use PPE recommended by the safety data sheet. PPE. To safely work with gel coat, a respirator, eye protection, impervious clothing, and gloves must be worn at all times. Patching preparation. Before removing the gel coat from the storage area, you'll want to make sure it's still within its commercial warranty period. You will find the commercial warranty period listed on the tech data sheet. The material age should be listed on the certificate of analysis or the container label. Follow first in, first out stock rotation. This will ensure you are always using fresh material. Store gel coat between 70 and 85 degrees Fahrenheit. Before you prepare patching material, make sure the gel coat has been properly agitated. Agitation is a key to maintain the correct cure and color of the gel coat patch. Mix the gel coat for 10 to 15 minutes prior to pulling the sample. You may need to set the mixer to a higher speed for the first 3 minutes to get the material moving. The speed can be lowered after the first 3 minutes. To agitate gel coat pails, use a small propeller mixture or shake the pail for 2 minutes in a 3-dimensional shaker. Patching equipment. To avoid diluting the gel coat with styrene or acetone, the use of INEOS MaxGuard CR03000 Pro Patch solution is recommended. This INEOS product contains a proper combination of resins, promoters, and surfacing agents. This product will be all you need to add to the gel coat. Refer to INEOS's Cosmetic Repair Guide for the proper ratio of gel coat to Pro Patch material for the type of gel coat you are using. Pro Patch material can be mixed either by volume or by weight. For the purposes of this video, we will show you how to measure a small amount of Pro Patch material using each method. Measuring Pro Patch by weight. Begin by setting the scale to 0. Measure out the appropriate amount of Pro Patch material outlined in the INEOS Cosmetic Repair Guide. Be sure to zero the scale before adding the gel coat. To ensure the best color match, use the same batch of gel coat that was used to build the part. Mix the gel coat and Pro Patch solution together for a full minute. Next, add 2 to 2.5% of MEKP initiator to the mixture, using the pipette with millimeter markings. Use a 9% active oxygen content MEKP type initiator for the best results. It is important to use the recommended catalyst level. The proportion of initiator to gel coat is vital to ensure proper patch cured. Do not exceed 2.5% catalyst or reduce below 1.5% catalyst in the patch mixture. Over-catalyzation of the gel coat will plasticize the patch and will reduce the cure. It can cause an off-color cure, veracity, and poor gloss. Under-catalyzation will not allow the patch to cure properly and can cause similar issues. Mix the patching gel coat with the initiator thoroughly for at least 1 minute. The pot life of the catalyzed patching mixture is roughly 7 to 10 minutes at 77 degrees Fahrenheit. You should patch at 65 degrees Fahrenheit or above. If faster patch cure is needed, or cool shop temperatures necessitated, warm the patch area to a maximum of 110 degrees Fahrenheit. It will be slightly warm to the touch. Measuring Pro Patch material by volume. First, measure the correct amount of Pro Patch material using a volumetric measuring cup. Next, measure the correct amount of gel coat. Refer to the INEOS Cosmetic Repair Guide for the correct ratio of Pro Patch material to gel coat by volume. Mix the Pro Patch material and gel coat together for 1 minute. Next, add 2 to 2.5% of MEKP initiator to the mixture, using the pipette with millimeter markings. Use a 9% active oxygen content MEKP type initiator for the best results. It is important to use the recommended catalyst level. The proportion of initiator to gel coat is vital to ensure proper patch cure. Do not exceed 2.5% catalyst or reduce below 1.5% catalyst in the patch mixture. Over-catalyzation of the gel coat will plasticize the patch and will reduce the cure. It can cause an off-color cure, porosity, and poor glass. Under-catalyzation will not allow the patch to cure properly and can cause similar issues. Mix the patching gel coat with the initiator thoroughly for at least 1 minute. The pot life of the catalyzed patching mixture is roughly 7 to 10 minutes at 75 degrees Fahrenheit. You should patch at 65 degrees Fahrenheit or above. If faster patch cure is needed or cool shop temperatures necessitated, warm the patch area to a maximum of 110 degrees Fahrenheit. It will be slightly warm to the touch. Best practice is to weigh and mix an entire gallon of gel coat and Pro Patch together. This will ensure all employees are using the same Pro Patch to gel coat ratio. The gel coat name and batch number should be recorded on the container, and it should be well mixed prior to each use. Establish a common container and a standard amount of gel coat to be used to ensure that all patching gel coat are prepared the same way. Spray equipment setup. The setup of your spray equipment is essential to the success of gel coat application. It is recommended that a top-loaded spray gun be used for application. A top-load gun allows you to spray with lower pressures and uses gravity instead of suction for material supply. Most of these also have a flow regulator to adjust flow from the cup. There are also pressurized cup versions, which will push gel coat from the cup when viscosities are high. You should not use spray equipment with propellant. This lowers the temperature of the gel coat, which can lead to solidified wax and greatly diminished spray pattern. Do not use spray equipment which acquires the gel coat to be further diluted or thinned. The addition of solvent can have a detrimental effect on the cure and color of the patch. Excessive thinning can cause pigment shock and can lead to bad color match on repairs. Low air pressure between 20 and 25 psi is sufficient to develop the spray pattern. Excessive air pressure will result in a rough surface on the patch, also known as orange peeling. Orange peeling is often difficult to sand out and may require the patch to be completely redone. Prepping and sanding the area to be patched. When prepping the area for spray, it is recommended to sand to a radius which will make your repair area larger. This will make the repair less noticeable. Dark colors on hole sides can be difficult, since many times they cannot be broken on the radius. Prepping with the proper grid of sandpaper and allowing overnight cure times will pay dividends for the boat builder because, in many cases, it will improve the color match. Before making a spray patch, sand the area to be sprayed by hand. The coarser grit gives a better repair, particularly with dark colors. 80 grit is a good place to start with no more than 129 grit for lighter colors. Sanding the area ensures a good mechanical bond of the sprayed patch to the part. A poorly bonded patch will peel when sanded. A poor mechanical bond may also result in a halo around the patch. Clean and check the sanded area for shiny spots that show through the scratches. Shiny spots indicate that the sanding is not complete. Continue to sand the area until the surface is completely dull. A clean or even sanding will result in an excellent mechanical bond and will reduce the risk of a halo. After thoroughly sanding, remove the sanding dust and other contaminants. Use fresh non-acetone solvent or a mild cleaning fluid to remove stubborn dirt and grease. It is important to have the surface clean and dry before making the repair. A dirty or contaminated surface will also have an effect on the bond. Water is not recommended as a cleaning solution because of the length of time it takes to dry. Using a ballpoint pen or China marker, draw a line just outside the sanding line. During sanding procedures, this line will indicate when the edge of the patch has been reached. When this line has been sanded out, the feathering of the patch edge should be nearly complete. This step will remove halos caused by incomplete sanding procedures. Mark off or tape off the repair area to reduce overspray. Rolling the edge of the tape can also help feather and soften the edge of the patch. Aperture tape in different diameters is also available to help soften the edge of the patch. Spraying a patch. Before spraying a patch, check your air supply for contaminants such as oil and water. To check for contaminants, spray air only onto a white towel or white rag. Water and oil will easily be seen on the white towel. If contaminants are present, do not spray the patch until the supply lines are clean. Spray the patch using the recommended spray equipment. Start the spray at the center of the sanded area and work outward in a circular motion toward the repair line, feathering toward the edge. A patch of 10 to 12 mil wet foam thickness achieves a better cure than a thinner patch. Curing a patch. For best results, allow the repair to cure for the proper amount of time. Do not over-catalyze to speed the cure, as this can result in a gummy, failed repair, which will need to be redone. Heat clamps or heat guns can also be used to cure the repair, but the temperature should never exceed 110 degrees Fahrenheit or be warm to the touch. The best option is always allow time for the repair to cure. At 77 degrees Fahrenheit, use a minimum of 2-hour curing time. Additional time is wise if wet sanding will be done after the cure. Darker colors will need longer time to cure before sanding and buffing. The longer the gel coat spray patch cures, the better the color match will be. A longer cure will also help eliminate the chemical line, or halo, around the patch. Make sure the patch is fully cured before sanding and feathering. The patching gel coat will film cure faster than it cures through. If the sanding and buffing process is started before the gel coat is fully cured, the spray patch will not feather properly and the optimum gloss will not be obtained. Halos may also appear. The darkest color should be allowed to cure overnight to get the best results. Use toluene, naphtha, alcohol, or non-abrasive household cleaner for cosmetic cleaning. Clean from the inside of the patch to the outside. If patch temperatures are 65 degrees Fahrenheit or below, heat lamps at 5 feet away or heat guns at 1.5 to 3 feet away can be helpful. Avoid heating the patch too early. Heating too early can actually extend the film cure of the patch rather than speeding it up. Risks of heating too much or too fast include deactivating surface agents, sealing the surface and trapping monomer, undercure in the interior of the patch resulting in discoloration. Heat guns can be difficult to use. The heat gun must be kept moving. Surface temperatures should not exceed 110 degrees Fahrenheit. Heating from the backside of the laminate repair is best. Sand the patch. Remember, the spray patch is probably no more than 10 mils in thickness. Be selective with your sandpaper choice. A good grit to start with is 220 to 320 grit paper. In most cases, 320 grit paper will remove any orange peel. After the orange peel has been removed with the 320 grit sandpaper, clean the area and resand with the next finest grit paper. The edge of the patch should be feathered into the surrounding surface at this point. If sanding is not completed and the patch edge is not feathered, a halo will be present. In flat areas, knock down the bump by block sanding in an X pattern to flatten the repair. The sanding process should be continued until the desired finish is obtained. Sand with the following order of grit to achieve the best results. By finishing sanding with a very fine sandpaper, you will produce the best gloss. Moving up in grit incrementally can speed up the process, leading to a better repair. Dry wipe to remove the sanding dust from the surface before sanding with the next finest grit. As you move up in grit, increase the radius in the sanded area. When using a DA sander, make sure the pad is clean and free of buildup. A DA pad that has an uneven surface will leave deep scratches that are difficult to remove. Run the DA sander at a medium or slow speed. Running the sander at a high RPM will cause the sandpaper to be less efficient and cause the sandpaper to clog or fill with sanding dust. The extent of sanding will vary from one gel coat to another. This is due to the difference in gel coat formulas. Some gel coats will require more time during the sanding procedures. If wet sanding procedures are used, it is very important to keep both the sanding surface and the sanding water clean. The sanding water should be changed frequently. Also, ensure that the sandpaper is clean. If the sandpaper falls onto the floor, it should be free of dirt or grit before being used. Do not wash the dirty sandpaper in the sanding water bucket. The sanding water should also be changed when the sandpaper grit is changed. Wet sanding techniques are used with grits of 600 or finer to achieve a smoother surface prior to buffing. Rubbing two pieces of sandpaper together with the same grit size will remove any oversized grit particles. This is a very old practice that works effectively to prevent random scratches in the film surface. Clean the sanded area with water and wipe dry. After the surface is completely dry, visually check the surface for any unsanded areas and deep scratches that may not have sanded out. If the surface looks good, you're ready to compound and buff. Avoid wiping freshly cured gel coat patches with acetone. The patch will absorb the acetone and cause the patch to become lighter in color. This condition is more prevalent in darker colors. Even after 24 hours, acetone can cause discoloration or spotting. Buffing a patch. When buffing a patch, a lower speed buffer will take out 800 grit scratches and in some cases will remove scratches from 600 grit sandpaper. Compound will effectively remove the scratches of the finer grit paper, such as 1200 and 2000. This will result in a much higher gloss. Use 100% wool buffing pads to reduce heat. Repairs buffed with polyester or polyester wood blend pads are not as durable. Wool pads remove scratches while polyester or blends may only polish the scratches. Water-based compounds are recommended for cooler buffing and reduced swirls. Choose a compound that is designed for the type of procedure you are doing. For instance, do not use a compound with a mechanical buffer that specifies hand rubbing only. A medium grit machine compound will usually take out 600 grit sanding scratches. When applying compound by hand, use a cotton cloth or small brush. Apply the compound in a thin layer over the area to be buffed. Do not rub the compound into the surface when applying it. This will cause scratches which can be difficult to remove. When applying compound with a mechanical buffer, use 1800 to 2800 RPM on the buffer with medium pressure to spread the compound evenly over the surface. Use a machine that has no more than 2800 RPM. Using a machine with a high RPM can create friction and heat buildup on the surface, causing the original gel coat surface to blush and not buff up to a high gloss. After the compound is spread, clean the pad with a buffing star or a tongue depressor. A clean pad will appear fluffy. Randomize the buffing pattern to avoid swirls or parallel scratches. Reapply the buffer to the surface again with medium pressure, moving it rapidly over the surface. As the compound starts to break down, reclaim the buffing pad. Repeat this procedure 2 or 3 times, reducing the pressure each time the buffer is applied until just the weight of the buffer is being applied. Repeat the entire procedure until all scratches have been removed and the desired gloss is attained. Be careful not to apply heavy pressure on the buffer. When heavy pressure is applied, heat is generated. This heat will dull or blush the entire surface as well as the path. Keep the buffer moving rapidly over the surface to avoid hot spots. When changing from one compound to another, use a clean buffing pad. When setting the buffing machine down, make sure the pad does not touch the floor or any other contaminated surface. Do not try to buff out deep scratches. If the scratches are still visible after 2 or 3 applications of buffing compound, sand the area with fine grit sandpaper and repeat the compounding and buffing procedure. If the compound is dry and difficult to spread, apply a few drops of water to the surface before spreading the compound with the buffer. This will help to spread the compound and act as a lubricant to reduce friction and heat while buffing. However, the use of too much water will cause the compound to build up or cake onto the buffing pad, causing the pad to leave deep scratches. The final gloss can be enhanced by the application of a high-gloss polish or wax. The proper patching techniques outlined in this video will minimize the appearance of patches, leading to an excellent cosmetic finish. For additional patching recommendations, please contact INEOS Technical Service.